Welcome to the Introduction to Python with Anaconda for Beginners. My name is Matthias, and I'll do my best to get you started with programming in Python. In this video, I'll explain what Python is and what it is used for. Then, I'll explain what Anaconda is and show you how to install it. We will then go over some basic Python commands and the syntax. I'll also show you how to run your program from the command line, and in the end, I'll show you some examples of advanced Python programs. To wrap up, I'll point you towards some resources that you can use if you want to dive deeper into Python. Let's get started. So Python is a general purpose programming language that can be easily used for small projects just as much as for large enterprise applications. It is best suited for web development, simple scripting, and data analysis, but its flexibility allows it to be used for much more, such as web scraping, game development, machine learning, browser automation, and Internet of Things. Python is able to do all this mostly thanks to all the various packages that extend its basic functionality and that the Python community continuously contributes to. Packages, also referred to as libraries or modules, are collections of code that serve a particular purpose and help you to speed up your development process. An example of a package can be random, which lets you generate random numbers. Python is also very easy to learn and understand. Before we start coding in Python, we will quickly go over Anaconda, which is a Python distribution that comes loaded with hundreds of packages that are especially useful if you are planning on using Python for data science and machine learning. Anaconda is still extremely helpful even if you're not planning on using Python for data science, because it comes with the Conda package manager and a virtual environment manager that make it extremely easy to work on multiple projects at the same time. All this means that Anaconda makes development with Python fast and eliminates all the headaches of tracking package dependencies. Unless you are an experienced programmer, I highly recommend using Anaconda since it allows you to skip setting up coding environments and allows you to jump right into the exciting part, coding. If you're an experienced programmer, this tutorial might not be too beneficial for you in the first place. Hopefully, I was able to convince you that installing Anaconda will be worth giving up a bit of your precious computer storage. If so, we will install Anaconda by going to www.anaconda.com/distribution. Anaconda will also install Python on your machine, so you don't have to download Python separately. Here, we will click the Download Now button and choose Python 3.6 version to download. You might have version 3.7, 3.8 or something higher. Do not download Python 2 as that is a deprecated version and some things might not work for you. While this is downloading, let's have a look at a very helpful resource, the documentation for Anaconda, which can be found over at docs.anaconda.com/anaconda. Or you can click the Anaconda Documentation link at the lower part of the downloads page. Whenever you run into a problem with Anaconda, this documentation and your preferred search engine will be your best friends. You can see that there's a lot of helpful links and information, like the cheat sheet or some information about Anaconda working with the pip, which is a different package manager for Python. On the left side, you can find the installation link, where you can find all the necessary help in case you have a problem with installing Anaconda. Here you can also find the packages link, where you can find all the packages that come with Anaconda. Let's quickly see all the packages that come with Anaconda, and since I'm running macOS, I'll click on macOS here. And on this page, we can see the list of all the packages that are supported or come pre-installed with Anaconda. There's tons of them, which is a huge reason for using Anaconda, because if you did not have Anaconda, you would have to install and manage these packages manually, which can cause a lot of headaches. Let's see if our installer downloaded yet. It indeed did, so now we can run it. This installer is quite easy to follow. Mostly we'll be just clicking continue, so let's do that 2 times. And on this page, we should notice that the installer is informing us about the fact that this installation will modify our path. What does that mean? Well, the path tells our operating system which directories to search through to find executable files. Modifying the path means that we add a piece of code that will point our computer to a directory with executable files. This will allow us to run various commands from the terminal window and is required for a proper functionality of Anaconda. Sometimes it is necessary for us to modify the path manually, but this installer will do that for us, which is great. We can continue with the installation. Now here are the software license agreement. We'll agree with this because if we don't, we cannot install it. And on this screen, we will have a quick look at the customize option. Here we'll see that the installer will install Anaconda 3. And if we click on that, it confirms right here that the installer will modify our path. You could tell the installer that you do not want to modify the path if you had a reason for it, but we'll leave this option alone. We can just switch back to the standard installation setting and proceed with the installation. Since I already have Anaconda installed, I'll let you pause the video, finish the installation, and come back when you're done with that. I hope that the rest of the installation process went without any hiccups. Now that you're done, let's quickly confirm that the installer added Anaconda in our path. I'm not good enough with Windows to guide those on those operating systems through the following couple steps, so I apologize for that. As long as you know how to change a directory, open a file, and list files in command line, you should be good to follow on your Windows machine. Open the terminal window and make sure that you are in your home directory. If you're not, you can make sure that you are by typing cd and tilde. Since I am, it will not change the directory for me. We will now need to find the file that stores the code that modifies our path. The code can be stored in 3 different files. The file names would be .profile, .bash_profile, or .bashrc. These files are always stored in your home directory, which is where we are currently located. And you might have one of those files, or you might have 2 of them, or even all 3. They all serve the same purpose, so don't worry if you only have one. To find which one of these files we have, let's list all the files in our home directory. To do that, type ls. This will list the files in our home directory, as you can see here. However, there are no files called .profile, .bashprofile, or bashrc. That is because the files that we're looking for are hidden. To list all files, even the hidden ones in our home directory, type ls-a. Now we can look through all the hidden files whose names usually start with a dot, as you can see, and we can find that I have bash_profile right here. You might have bashrc, or you might have just that profile. Let's check the content of this file to confirm that the installer added Anaconda to our path and how it did it. To open the file, type pico and the name of the file, which in my case is .bash_profile. But in your case, it could be bashrc or profile. If I click enter, I open the file, inside of the file, I can see all the contents, and I can see 3 lines of code. Each of them adds a different directory to our path. This line, for example, tells the operating system to search for executable files in the Anaconda 3/bin directory. The line right above is adding a directory for my dev desktop app to work. The first line is adding 2 other directories. One is here, and the other one is here. They're separated by the column. If you install a program that did not automatically modify your path, this is the file that you want to access and edit. We can exit this file by pressing Ctrl and X. You can actually check all the file paths that are in your system's path. To do that, type echo $, and capitalize path. What you can see here are all the individual paths that your computer is looking into for executable files. Right here, the last path is the Anaconda path that the Anaconda installer added. So what this allows us to do is to run various commands through the terminal window, like installing new packages with conda install. I would do conda install and then the name of the package. Or I can check the version of Anaconda that we're running. I would do that with Anaconda -V. This will show me that the version of Anaconda that I'm running is 1.6.9. And now we should have a good understanding of path and how our computer knows where to look for executable files. We have now successfully installed Anaconda and we understand how path works. We can now try to open Anaconda. We have 2 options. We can look for it among all of our applications, which would be right here, Anaconda Navigator, or we can type Anaconda Navigator and press return. Anaconda Navigator. So this command works thanks to our path, which the installer modified. If we press return, we should see that the Anaconda is opening now. Okay, so on the left side, you can see that there are a couple of tabs. We won't be using them too much, but it is good to know what is inside. In the Environments tab, you can create and manage environments. In the Learning tab, you can find some articles and learning resources, videos, and in the Community tab, you can join various communities where you can learn as well. There are a couple of applications on the main board that Anaconda comes with, like Jupyter Lab, Jupyter Notebook, and Spider. We will be focusing on Spider, which is the integrated development environment for Python that comes with Anaconda. Let's launch it. Since Spider is the place where you will spend most of your time while coding, let's get familiarized with it a little bit. On the left, you have the text editor, right here. Here, you will write a large piece of code that you want to save and execute repeatedly. In the upper right part, you can switch between Help, File Explorer, and Variable Explorer window, depending on what you need. For example, I can type int into the Help window, which will display information about the int function. In the lower right part, you can find a console where you will spend a lot of time while testing your code. So the editor is where you will be writing your programs, and the console is where you'll be trying short pieces of code. Before we start writing a program, let's try to play a run in console for a little bit, so we can understand the Python syntax. To do some simple math, all we need to do is type the operation we want to execute and press return. Let's try to type 2 + 3. What we just typed is an expression, which consists of a value and operators. The two values we typed are 2 and 3. The operator is the plus sign. Expressions always evaluate down to a single value. In this case, the expression 2 plus 3 will evaluate down to 5. You can see that Python took the expression 2 plus 2 as an input and outputted a single value 5. You can also do other types of expressions like multiplication, for example 4 times 5, or division, like 10 divided by 2. With this, we introduce the first data type, integer. Other common data types are strings, floats, and booleans. Strings are sequences of characters, and we usually use this data type to store words and sentences. Unlike numbers, strings have to be surrounded by quotation marks. Let's try to create a string hello. Don't forget to put quotation marks around them. And we got a return of a string hello. We can also perform some operations on strings, like adding two strings together with the plus sign. Let's try adding hell and o. Plus o. This is also an expression, and then that consists of two values, hell and o, and plus operator sign. Again, this expression, like any other expression, evaluates down to a single value, in this case, hello. Another data type is a float. Floats are numbers with decimal points. Just like with integers, you can perform mathematical operations with them. Let's try to multiply 2.3 times 4.4, and this expression evaluates to 10.12. Another data type is Boolean, which can be either true or false. It can only have these two values. It is not common to use traditional plus and minus operators with Booleans. Instead, we use and or operators. The and operator says that the Boolean value have to be true for the expression to evaluate down to true. For example, the expression true and true will return true. If we say true and false, true and false, the expression will evaluate down to false, because one of these two values are false, and for this expression to be true, when there is an and operator, both would have to be true. The or operator says that we only need one value to be true for the expression to evaluate down to true. For example, true or false evaluates to true. True or false will evaluate down to true. True or true will also evaluate down to true. The only way to make this type of expression evaluate to false is to type false or false. Values and expressions are essential for programming, but they would not be too useful if we could not store them. Good thing that we have variables. With variables, we can store values for later use. We can also store expressions, since they always evaluate down to a single value. To store a value in a variable, we use the assignment statement. The statement consists of a variable name, an equal sign, and a value. Let's try to store the string hello in a variable called foo. Let's type the variable name foo, the equal sign, and the value hello. Here, this part is the variable name, this is the equal sign, and this is the value that we're trying to store. If we press return, we can see that in our variable explorer, the value came up. Now it shows us that we have a variable called foo that has a value hello. The data type of the value is str, which stands for string. You can easily override the value in the foo variable by assigning a different value to it. Let's try to do that. Type foo, the equal sign, and 1 plus 2. Now, remember that this is an expression that will evaluate down to a single value. 1 plus 2 will evaluate down to 3. So when we press return, the variable foo has been overwritten. Now the new value is 3, because 1 plus 2 evaluated down to 3. The type is no longer string, but an integer. Now that 3 is stored in foo, we can use foo in an expression. For example, let's try to add foo to 4. Foo plus 4. The expression will evaluate down to 7. This is because when Python is evaluating expressions, it replaces the variable with whatever it stores. Since foo stores 3, it replaces it with 3. So in the end, typing foo plus 4 is the same as typing 3 plus 4. There's one more data type that we will be using today. The name of the data type is list, and list is used to store multiple values. If we wanted to store the number 1, 2, and 3 without lists, we would need to store each one of them in a different variable. With list, store all of them in a single variable, just like this. 1, 2, 3. The list starts with an opening square bracket and ends with a close square bracket. The values that we store in a list are separated by commas. This is the first value in the list, and it's 1. This is the second value in the list, and it's 2. This is the third value in the list, it's 3. It is important to note that the first value in the list has an index of 0. The second value on the list has an index of 1, and the third value in the list has an index of 2. Let's try to store this list inside of a variable called bar. Bar is equal to 1, 2, 3. Now, when we press return, you'll see that in a variable explorer, we'll have a new variable stored. The type of the variable is list. The name is bar, and the value is a list that consists of 3 different values. Now, if we call the variable bar, what we will get is a list of 3 values. If we wanted to return a specific value from the list, for example, the first value, we can do that by adding a square bracket after the variable call, like this. Type bar, let's try to return the first value in the list, which is in the index of 0. So we'll type 0 in the square brackets, and when we press return, we'll get the specific variable we called for. If we wanted to return any other value, all we need to do is call for the variable with the square brackets containing the index of the value. Let's say we wanted to return the second value in the list, which is 2. All we need to do is call bar, opening square bracket, the index, which is 1, and close square bracket. Now when we press return, we'll get the value 2. Now that you know basic Python syntax, we can create a simple program. As I mentioned earlier, there are a ton of things that can be done in Python. Unfortunately, covering how to write complex programs with a lot of packages is beyond the scope of this short video, which means that I will only show you a short program. What we will create is a restaurant picker. This restaurant picker will store restaurants in a list, and a random number generator will choose a restaurant from said list. We will also be able to add and delete restaurants from the list, as well as list the restaurants that we have stored. In this program, we will also use loops, conditionals, and functions. If you have never heard about any of these terms, try to follow along, as they are quite easy to understand. A quick search on the internet can also help you in case they do not make any sense at all. Remember that it is not necessary to understand every single statement in the code. Rather, try to understand the bigger picture. let's get started. To open a new file, you can press Command N or go to the file and press New File. What we will need to do is create a list. Let's call it restaurants list. And this list will store some restaurants. We can do Boloco, Clover. Oh, don't forget to put quotation marks around your strings. And let's do Sweet Green. Sweet Greens. I think that should be enough for now. These are the restaurants that the program is going to pick from when choosing a random restaurant. That reminds me that we need to import a random module. Import random. This module will choose a random number and help us determine which restaurant to go to. Here, the program is just telling us that random has been imported, but we haven't used it in our code, which is fine. We'll use it later. To pick a random restaurant, we'll try to call the random number generator. Will generate a number in range that we specify in the parentheses here. If we do 0 to 2, it will do numbers from 0 to 2, 0, 1, 2. Now if we restaurants list here, if we run this, well, of course we have to save it first. Let's call it restaurant picker. Save it. Now if we run this file, nothing happens because we have not printed it on the screen, so we'll have to use the function print. Now if we run it, we're going to get a random number, a random restaurant. This time we got Sweet Green. If we run it again, we're going to get something else, or the same. Let's try to run it again. We got Boloco. Now we got Clover. Now we got Sweet Greens again. So this is working. What we need to do now is put it into a function. So we'll define a function called pick restaurant. And we'll put this print statement inside of the function. So this is a function definition statement, and inside of the function is a print function that will print the random restaurant. Now we also want to have a way to add a new restaurant, so we'll define a function that will allow us to add a restaurant to our list. Let's call it add restaurant. This function will take one parameter, let's call it name, and all we need to do is say restaurant list dot append. This is a method of the list object that will take value and we'll pass it to the end of the list. So restaurants list here. If we run this object, run this, and if we say add restaurant and then put a name, let's do dig in. You will be able to see here in the variable explorer that dig in will appear at the end of the list. Here it is. So this is working, that's great. let's define a function that will remove a restaurant from this list. Let's call it remove restaurant. This function will also take the name of the restaurant we want to remove. And to remove something from the list, we'll call the name of the list. Remove restaurant dot remove. Oh, apologies, not remove restaurant, but restaurant list dot remove restaurants list remove, and that will take the parameter. So now if we call remove restaurant and say we want to remove Boloco, you'll see here that Boloco will be removed from the list. There it is, it's gone. Now you might notice that Digin is no longer here as well. That is because this list is initiated every single time we run the program. So every single time we run it, the list will be created from scratch. So now when I run it again, Boloco is back here. Oops. Now let's create a really simple interface for the user to use so that they don't have to type remove restaurant, add a restaurant, and pick restaurant every single time they want to use this program. We'll use a while loop for that. So while something is true. So this is an infinite loop, and you would not want to do that. You have to make sure that there is a way for the user or for the program to end this loop. And we'll do that with the break statement. But if you were to run an infinite loop, your program will not work. So what we want to do is print a little message for the user and give them some options that they can choose from. So the first option would be to list all the restaurants. And we have not yet implemented this function, but we'll do that soon. The second option would be to add a restaurant. Add restaurant. The third option is to remove restaurant. The fourth option will be to pick restaurant. And the fifth option would be to exit the program. So this add a restaurant option will utilize our add restaurant function. Remove restaurant will utilize remove restaurant function, and pick restaurant will utilize the pick restaurant function. Now if I were to run this program, you'll see that this message will be printed to the user over and over and over again until I stop it with Control-C. This is what happens when you have an infinite loop in your program. Let's try to do that. I'll show you how it looks. So you see how it's being printed and printed and printed over and over again. I will stop the execution of the code. I'll attempt to. Oops. So I've used Control-C to interrupt the execution of the program. Otherwise it would have ran forever. Now we'll add some if statement. Before that, we'll have to ask the user to select one of these options. We'll do that with an input function. So in the input, we'll ask the user to please select an option from the, please select an option. That's good enough, I think. And save the selection in a variable. Let's call the variable selection. Now, once they select, we'll run their selection through a series of if statements and determine which of these functions we want to run. So if selection is equal to 1, so here he will implement the list restaurants a little later. Else if this is not true, it will go to the next line of the code, which is here, and check whether this one is true or not. So let's say selection equals to 2. And if selection is equal to 2, we will want to add a restaurant. So what we'll do is add, call the function add restaurant, add restaurant. Now we also have to ask the user to input the name of the restaurant that they want to add. And we'll do that again with the input function. So in name is equal to input, and we'll ask the user to input their restaurant, please, or we have been nice enough to them here. We can just say type name of the restaurant, and here in the parameter we'll put in name. Else if neither of these are true, we'll go to the next if statement, which is here, and it will check whether this one is true or not. 3. So if they select 3, we'll want to remove the restaurant. In name. Again, we'll have to ask them for the name of the restaurant they want to remove. Please type name of the restaurant that you want to remove, that you want to add. Let's just add a little bit more clarification so they know what kind of what is happening. Now we'll call the function remove restaurant, and input the parameter in name. Then we'll go to another if statement. If selection equals to 4. So each of these will determine whether the if statement will go to the next if statement or not. If this expression will evaluate to true, the code inside of the if statement will run. So if the user inputs 1, then the selection here will basically be replaced by 1, and 1 indeed does equal to 1. So that would mean that this expression would be 1, or it would actually look like 1 is equal to 1, which does evaluate to true. I'll prove it to you here. This evaluates to true, which means that this expression would evaluate down to true, and the code inside of this will run. Let's change it back to selection. The same would be true for this. If user selected 2, then this would return false, because 2 equal 1 will evaluate down to false. It would go to the next if statement, which is here. It will check whether 2 is equal to 2. That would evaluate to true, and the code inside of this if statement would run. The next selection would be to pick a restaurant, so we would run the pick restaurant function. Now this function does not need any parameter, hence we do not need to ask the user to input any. And the last option the user has is to exit out of the system. So let's say elif selection. Elif stands for else if. So if, else, if this is true, run this. Else, if this is true, run this. Else, if this is true, run this, and so on. So if this is equal to 5, break. So this statement right here will exit the infinite loop. At this point we can actually try to run the program, I believe. Expected indent block. Okay, so it actually wants us to write something in here. We have no function to put in there yet, so let's create one. Let's define a function. List restaurants, and in this function we will go through every single item in the restaurant list and print it. So for each restaurant in restaurants list. So what this is saying is for each item, or for each value, which would be Boloko, Clover, and Sweet Greens, in the restaurants list, do something. So anything that is in here will be done for every single value in the list. What we want to do for every single value in the list is to print it. So what we'll do is just say print restaurant, and now every time we call this function, the function will go to the restaurants list, go through every single one of these items, and print them. We can add the function into our if statement. Say list restaurants, and since we do not need any parameter, it will just list all the restaurants. We don't need to ask the user for the input. There must be an error. Here, I'm missing an U here. Should be correct. No, it's correct. Let's save it and let's run the program. If I click run file, I'm being prompted to make a selection. So what it did is print this part of the code. Now it's asking me to make a selection right here with this input function. So what I'll do is say I want to list all the restaurants. So I'll click 1. Now it listed all the restaurants here, Boloko, Clover, and Sweet Greens. It looks kind of sloppy because it printed it right after my selection. So we can make it look better by printing an empty line so that there is a little space between this line of code and this line of code. So just print an empty line. Now if I wanted to add a restaurant, let's try to do that. Let's try to press 2. Now we're asked to add a restaurant. Let's add dig in again, dig in. Let's press return. Now nothing happened, or at least nothing seems to be happening. But if I press 1 again to list all the restaurants, we'll see that dig in is now here. So dig in is part of the list. If I want to remove restaurant, let's press 3. Let's try to remove Clover. Let's press return. Now again, nothing seems to be happening. We could implement a little message to the user somewhere down here below that would say you have successfully removed Clover from the list, but we don't have to spend time on that right now. But to check whether it has been removed or not, I can just press type 1, press return, and I'll see that Clover is no longer part of the list. Now if I were to accidentally type something else than one of these 5 numbers, if I press L, for example, type L, and press return, it just went through the loop again, because while this loop is true, it will always run. So it would be good to write a little message to the user about what happened, why he's being asked to input something again. So the final part of our code will be else. And if none of these are true, then the last statement right here would run. And we want to say something like, error, please select one of the options above. So now when we run it and the user makes a wrong selection, it will tell him that there was an error, he didn't select any of the correct options, and ask him to select one of the options above. Let's try to exit this program for now. Let's press 5. The program is done executing. Now we have to run it again so that all the changes we have made in the code will take place. Let's try to press L again. We typed the wrong option. It tells us, error, please select one of the options above, which is exactly what we wanted. If we wanted to make we wanted to have a line between these two messages, we can just put a line break. So we would put \n. Now if we were to print it again, I would actually do that. There would be a space between the two, so it'll look a little nicer. Type L, press enter. There is a little space between the two. We could do that in every one of these messages so that everything is nicer. We have no two messages right next to each other, but for now it looks pretty good. Now there's one more thing that needs to be done before the program is completely finished, and that is to make this random integer generator flexible depending on how many items we have in our restaurant list. Right now it will return numbers from 0 to 2 randomly, and depending on what it returns, it will select one of these items in the list. If it returns 0, it will return the first item. If it returns 1, we will get the second item. If it returns 2, we'll get the third item. But if we were to add one more item to our list, which we can do with this add restaurant function, this restaurant would never be picked because this random integer generator will never return the number 3, which is the index of this value. So what we need to do is look up the length of this list so that this random integer generator can return values depending on how many items we have inside. So what we need to do is call the length function, and we'll put the restaurant list in there and list. So this length function will return a number depending on how many items we have in this list. So we'll return, in this case it will return 4. 1, 2, 3, 4. But what we actually want is 3 because we want the index, not the actual length. So what we need to do is do -1. So now it will return numbers from 0 to 3. Let's try to run this. If it works, let's save it. We have an error here on the restaurants list here. Now it should work. Let's run the program. Let's pick a restaurant. Sweetgreen, Clover, Sweetgreen, Diggin, Loco. So it was able to get the last item in the list, which is exactly what we wanted. It works properly now, and we can be pretty happy with the program. There are some things that could be done to make it even better, but for now, it's pretty good. Now that you have finished writing your program, let's try to run it through the terminal, so you don't have to open Spider every single time you want to use this program to select the restaurant for you. Let's open a new window in my terminal, and here we'll have to go to the location where the file is stored. In my case, it's on the desktop, so I'll type change directory and go to desktop. Now that I'm on desktop, I can list the files in here. You can see that I have 2 files, which I indeed do, and we'll have to change the permissions of our restaurant picker.py file. To do that, type chmod plus x, and now you have to type the name of the file that you're trying to change the permissions to. Restaurant picker.py, press return, and the permission should be changed by now. Now if you want to run it, all you need to do is type dot slash and the name of the file that you want to run. In our case, it's restaurant picker. If I press return, I should be prompted with something we have already seen. If I press 1, it'll list the restaurants that I have stored, just like everything we've done before. If I press pick, it'll pick one of those 4 restaurants. It picked Sweet Greens. If I do it again, it's Boloko. If I click 5, it will exit this program. In the last part of this tutorial, I would like to show you a more complex file or program that can be created with Python. I'll pull up a program I wrote while preparing for the Intro to Data Science class that is offered here at Suffolk. This program accesses the World Factbook, which is located on the CIA website. It would be, let me just pull it up really quick. The program collects some interesting information about every single country in the world and saves it into the CSV file. So the type of the information it is looking for is area, GDP, roadways, and railways. The type of the program that this is called web scraper. It scrapes data from a website. I'll also show you the website that it scrapes the data from. Go to Safari, open a new page. So there's a list of countries. Here's all of them. It's more than 150 countries that it goes through, and for every single country it opens the web page, finds the area, the total area. It also finds some information about GDP, which is somewhere down here, I believe. Economy, it finds the total purchasing power, and it also finds the length of the railways and roadways. So the length of the roadways is right here. So you can imagine how long it would take you to do that by hand, to go through every single one of those countries and get that information. Now if I run it, it will run for a little bit, considering that it goes through over 150 web pages. So now you can see the program is done running. It took actually much longer than I expected. It took around a minute for it to go through the 150 pages. We can open the file right here. It's the output file, cia.csv. Let's show it in Finder and look at the data. So for each of the countries, it found the country name, it found its code, the area, the road length, the railways length, GDP, and put it into this CSV file. There is not over 150, it's 269 different entries. So this program went through 269 web pages and collected this data. So the fact it took it a minute is pretty good, considering it had to download every single one of those web pages. So this is the end of the tutorial. I really appreciate your time, and I hope I was able to teach you a thing or two. If you're interested in learning more about Python, I would recommend looking into a book called Automate the Boring Stuff with Python, which is an excellent resource for beginners. It will teach you all you need to know, not just about Python, but programming. It's a pretty good start. You don't even need to buy the book because the author distributes it for free in an HTML form on his website, which is listed on the screen. The website is automatetheboringstuff.com. If you prefer to learn from a PDF or hard copy, it's worth the $20 or how much it costs to buy it. I learned a lot from it. Another good resource is datacamp.com if you're interested in using Python for data science. It will teach you much less of the basics, but if you already know that, it's an amazing resource. The Information Systems Club at Suffolk University can also give you access to all the paid content because datacamp.com was very kind to give them complimentary access to all the club members. Also, if you wish to give me feedback or have any questions about this tutorial, I'll be really happy to chat with you. You can reach me at mklabowski@su.suffolk.edu. And for now, happy coding. Thank you again.